Good morning or good afternoon, everyone. Thank you so much for coming along to this webinar, Research Quality and Reproducibility, Ensure that Researchers are Engaging in Responsible Conduct with Epigeum's new course collaboration. We should only take about 45 minutes of your time, including the designated question and answer session at the end. If you are familiar with the GoToMeeting software that we are using, you know that there is a question option as part of the panel on the right-hand side of your screen near the bottom. If you would like to ask a question as they occur, please feel free to send them over and we will answer everything at the end of the webinar. Also, we are recording this webinar, so if you wish to view it again or to share it with your colleagues, it will be available on Epigeum's YouTube page next week. At the moment, you're all on mute just to avoid any background noise, but again, if you have any questions, please feel free to ask them in the panel on the right. So now just a couple of introductions. That's me, Anne-Marie Turner, on the left-hand side. I am the marketing manager for Epigeum's research courses, which will include research quality and reproducibility. Also, as just a quick aside, throughout this webinar, we will commonly refer to the course as RQR, just to be aware of that. Now I'm going to ask Dr. Rebecca Davies and Sarah Andrus to introduce themselves. Dr. Davies?
Thank you. Hello, everyone. It's so nice to be with you, and I'd also like to thank you all for joining this conversation, and I look forward to hearing your questions or concerns. As Anne-Marie mentions, I'm a faculty member at the College of Veterinary Medicine, where my interests include comparative animal endocrinology and veterinary diagnostic medicine. However, for the past 5 years, my focus really has been on the development of a program called Quality Central, which is a program with a mission to help researchers integrate research quality assurance best practices into their academic research environment as a way to support and demonstrate, which is a very important piece here, I think, their ability to conduct rigorous and responsible research. So research quality assurance skills are really rarely taught in the academic setting, and I think that our scientists are missing out on important tools that could be used to enhance the quality of their work. So I've been working individually to create training programs in this area for our college, but I see a need for standardized, convenient, flexible, and well-tested programs that could be adopted by many scientists in many institutions. And that's why I became very interested in Epigeum and its approach to the development and evaluation of research training content. I really admire their consultative model and collaborative model that will bring many voices to the table. And that's why I'm really looking forward to participating as a lead advisor for the Research Quality and Reproducibility course.
Thank you, Dr. Davies. Sarah, would you like to introduce yourself?
Sure, thank you so much. My name is Sarah Andrus, and I am the commissioning editor on this project, RQR, with Epigeum and Oxford University Press. And so that means it's my job to manage this collaboration project from start to finish. And I've had the pleasure of working very closely with Dr. Davies and other advisors and collaborators who we've got some really fantastic feedback from. So I look forward to discussing this project further on this webinar and hearing some of your questions and feedback as well.
Fantastic. Thank you so much for joining us today, ladies. So just a quick point onto our agenda for the day. First, I will be providing a bit of background about Epigeum itself and about how our courses are run here. Next, we will move on to Rebecca's presentation on the background and vision of research quality and reproducibility. And then Sarah will present her course overview and discuss how an Epigeum course is developed. We will then wrap up with a Q&A. And as I mentioned before, please feel free to write any questions in the panel on the right. Epigeum was founded in 2005 as a spin-off from the Imperial College London. Our two founders created the company in response to what they felt was a lack of timely support for researchers. At the time, one of our founders was getting his PhD while also working full-time when he came across issues that he wanted and needed to be advised on. The courses he needed to take either had to be face-to-face courses at a university that would start over 3 months after he needed to take them, or he would find online material that was dated or inadequate and that didn't quite fit his need. He saw this as an opportunity to work with universities to create supportive materials for researchers, particularly PhD students and postdocs like himself, that gave immediate support for all those issues. And that's where Epigeum started. In more than the 10 years since, we've expanded from our first study program for students to include also research, teaching, and leadership and management courses intended for both staff and professionals. Epigeum was acquired by Oxford University Press in May 2015. Since OUP is a division of Oxford University, Epigeum is still a not-for-profit organization in a higher education context and still very much focused on creating higher quality materials. To date, in the decades since we've been founded, we have created over 92 online courses across 19 different programs, and we currently have 4 in development, including our QR. We're a globally focused organization, as you can see. We've worked with over 280 universities across 30 different countries worldwide to date. Our implementation of courses is unique, so I would like to take a moment to discuss that. Firstly, our courses can be used as a standalone academic course. You can supply the student with an online, multimedia-rich course immediately at the time and the place they need it. This would be a self-study mode. The advantage here is that you can make the course quite personal and release training on demand. So this is the most flexible option of the 3. Secondly, we have the option for tutor-supported online courses. With these courses, there are plenty of supplementary materials available, and they can be used by tutors to enhance the course. A tutor can be used to provide feedback that cannot be provided by computers. They can work on community-based features, give motivational messages, etc. So there's a whole tutoring side to the course that can be used if you have the tutors. The advantage here is that the course is allowed to be more effective, but you do lose flexibility as you would tend to have a fixed start and end time. Finally, and this is the most common use for our courses, it can be used as part of a blended learning program. Typically how this works is that the students are given access to the online course ahead of a workshop. And then the workshop would really focus on the consolidation and application of the material. This is considered to be maybe the most effective pedagogically, but it's also the least flexible. Thus, you have a spectrum here that's the most flexible to the most pedagogically effective. So if you can implement the course in all 3 modes, together these 3 methods of implementation provide you with quite an armory to get your students the support and knowledge they require. Now that we've had a bit of background about who we are as a company, I'm going to pass it over to Dr. Davies, and she is going to present on the vision for the course, Research Quality and Reproducibility.
Thank you very much. So just to begin with our hopes and dreams for this course, I'd like to talk about the objectives. And the objectives are, as you see written there, that we hope to provide content that will ensure that research scientists can develop the skills required to plan and execute well-managed and reconstructible scientific research, with the focus being on better outcomes for research reproducibility. The course is designed, and the Epigeum approach is quite nice, I think, in that they've recognized that many of these issues need to span the career arc of the researcher. So the goal is to provide training that's tailored to the needs of the researchers wherever they are in their careers, from undergraduate research experiences to the leaders in the academic and corporate scientific community. So what you see here is the Epigeum diagram of the arc of the researcher, and you see the academic research track on the top and the corporate research track toward the right. And along the way you see the typical and traditional pathway from undergraduate students who are just developing their interest in science and learning some of the tools of being an experimenter, all the way through our traditional training programs, graduate student, postdoc experiences, through to becoming research administrators or research directors. And what's important along this pathway is that, of course, we're interested in building skills along the way and adding skills along the way. All of those skills need to incorporate aspects of research quality and issues related to research reproducibility. And you see some of those skills indicated on this slide. So as we begin to think about the research reproducibility issue, I'm sure many of you have heard about this issue, have reviewed some of the papers. This slide in front of you is data captured in an article written by Monia Baker and published in Nature in May of 2016. And basically this was an opportunity for scientists that read Nature to engage in a survey. And the results of the survey are shown in this slide in terms of the question of whether or not a reproducibility crisis actually exists. And you'll see here that there were a group of over 1,500 researchers who answered the survey, and of that group, a large number believes there is some kind of crisis, either a significant one, 50%, or a crisis of some sort. And then there's a much smaller number that either aren't familiar with this problem or believe that there is not a crisis. So this indicates that at least of these readers of Nature, there is some sense, in a large sense, of a problem with our ability to meet our expectations for our scientific research, which of course are that our data should be reproducible. A second question asked in Monia Baker's article were whether or not scientists had established procedures for reproducibility. Now understand that the respondents to this survey were multiple disciplines of scientists, so most of them were biological scientists, but there were also physicists, mathematicians, and among that group we see that 34% indicate that they really haven't established procedures for reproducibility. Others say that within the most recent past, within the past 5 years, they have put in some procedures, and others say that they feel confident the procedures have been in place for most of their work. So this indicates that about a third of our scientists feel like they have not accounted for the potential for problems with reproducing research, and others are working in that area. And as you see on the slide, most of the most popular strategies are having different lab members redo experiments, which is sort of our traditional approach to our research, is can we replicate our results. So the other issue, in addition to research credibility problems or concerns among scientists, among the public, are this concept of research wastage. This paper that you see on the slide was written by Friedman and colleagues, who's an economist, and in this paper he indicates or estimates, based on his review of the literature, that irreproducible biology research costs come up to $28 billion per year, and I'll show you a slide later that indicates that's about half of the entire United States research budget. And he makes the point here that the major cost doesn't lie with the faulty initial study. We're not saying that scientific research has major flaws, but there are problems that occur, especially on follow-up where work is not able to be reproduced, and that means that we may be pursuing false leads or delaying alternative discoveries by wasting our time on work that can't be reproduced. Now, this is a slide that reflects the data that suggests that half of our research is not reproducible. So what you see on the left is the column showing that the estimated U.S. annual research spending is about $56 billion, and half of that was deemed to be irreproducible. And that was based on his review of the papers and looking for errors or omissions that would allow another scientist not to be able to replicate the work. Now they took that a little further and try to categorize what were the problems that made that work irreproducible. And those are the categories that you see on the right of this slide. Through their analysis, they believe that over a third of those irreproducible research results, the problem was due to the fact that biological reagents and reference materials were not accurately described so that other scientists could identify them, get access to them, or replicate their effectiveness. Study design is also a problem. Up to 28% of the study design was flawed. Another near third, data analysis and reporting. There were problems with the analysis, with the tools used, or with the reporting that resulted in research that couldn't be replicated. And then about 11% of the laboratory protocols were not sufficient to repeat the work. So this provides some places to start. And you'll notice, if you're familiar with what the National Institute of Health is currently recommending, you know, several of our scientific stakeholders, the funders and the publishers, have noticed the problems with our research replication as well, and they are taking some strong measures to try to improve this. And in the U.S., the NIH has obviously responding to the sort of data we saw in the Friedman paper, and they're now asking scientists to provide additional information in their grant applications in the hope of enhancing rigor and reproducibility. And I mention these because these should be our targets as well in terms of our training programs. But if you recall the previous slide where they mentioned that there are problems with reagents and protocols and statistical analysis, you can see that these four categories indicated on this slide, that the NIH is asking us to work a little harder in those areas. So the scientific premise, can we support our hypothesis? Rigorous experimental design. Here we are with the consideration of sex and other relevant biological variables, and then the authentication of these resources or reagents. Now, in their work to drive and improve standard, the NIH readily suggests that their efforts alone will not be sufficient to affect real change in our current environment. And so this is where institutions and academic settings are being called on to become active in this area as well. So currently we have activities from the funding agencies and from the publishers that are trying to help us address these issues, but there is a real call for institutions to engage in this as well. This is another article from Nature in September 2015, and I like this diagram because I think it reflects sort of our new reality where we have this sense of science kind of falling down around our heads, in that what you see are the funders on the far left held together with Band-Aids, and the publishers in the middle also starting to crack, and what looks to me like a beleaguered scientist wondering how they will meet the expectations of the scientific community, and then the institutional representative at the far right that appears to be a bit asleep at the wheel. And so this paper is really challenging us to consider ways as institutions to support the scientists and to help address research reproducibility. And they do that by recommending what they call good institutional practices, which I've indicated as GIP there. So these good institutional practices, really the suggestion is that we need to focus on the activities of scientists at all levels. And if you look at this slide, we have highlighted where the science is being produced, of course, who's at the bench, who's driving the science in our institutions. And as you look at this, you remember the arc of the researcher, and the colored columns here indicate the kind of course organization that Epigeum is working on. And the research quality and reproducibility course that we're talking about today is really designed to support the development of skills of these scientists who are at the bench doing the foundational and basic research that will feed on to translational research or to the roles of research leaders. So basically what we're trying to construct or work on is a way to support scientists in all the pillars of scientific investigation. On this slide you see what we traditionally consider science as being a combination of strong research ethics, strong research integrity, and then combining that with best practices for quality and reproducibility, and of course the whole umbrella of sound science going across these. When we think of the support we have in academic institutions, we typically do have the ethics pillar fairly well represented in that there are responsible conduct of research courses, there's support for scientists and learners in what constitutes research ethics and what constitutes research integrity. And those pillars tend to focus on plagiarism, fabrication, and fraudulent science, but they focus much less, if at all, on the best practices that contribute to research quality and I believe will have an impact on reproducibility as well. So in our current environment, we do know that funding agencies agree that there's a need for increased attention. They also agree that transparency and rigor should be discussed and encouraged amongst all members of the research community, including students, technicians, assistants, faculty, leaders, and other staff. And this, I think, fits well with the vision of Epigeum and their career arc. So the question of what's needed is an interesting conversation and can be variable and address multiple issues. This is a quote from the Nature article by Monia Baker where she summarized the review of those 1,500 plus scientists. So Judith Kimball from the University of Wisconsin raises a good point when she says that everyone is stretched thinner these days and the cost extends beyond a specific research project. Her example is if graduate students train in labs where senior members have little time for their juniors, they may go on to establish their own labs without having an appropriate model of how training and mentoring should look, which of course will go off and make it worse. This is just one example of the kind of issues that scientists are dealing with at the moment. So there's a lot of information on this slide, and I mainly show it to you because I think it gives a nice image of where Epigeum is trying to go and is encouraging consensus and collaboration to develop courses for this project. And what you see here in the columns are the topics that we're hoping to address in the course. And the one that I've circled is the research quality and reproducibility content, which would be that pillar where the research scientists are most active in generating research data. So we're working on constructing training materials that will help researchers develop, plan, execute, and very importantly communicate and demonstrate their work. And what you see in orange are the topics or the targets that the NIH, that the publishers, that scientists themselves have identified as being areas that they would like to improve. So for instance, the research premise is one of the targets for the NIH new requirements. Experimental design has been identified by the NIH, by Friedman in his article, but also by scientists themselves as being an area that they would like to improve. I think we would all agree that research documentation, management, and monitoring is an area that we could help scientists improve. And then along every aspect of the training program Epigeum is designing is going to be a focus on mentoring, both from the point of being a mentee and from the point of a mentor. What can we do to strengthen those relationships, especially in terms of research reproducibility focus? So I'd like to finish with this slide. This slide is taken from the World Health Organization, who way back in the early 2000s made available a very nice document helping scientists if they wanted to voluntarily integrate some research quality assurance best practices into their biomedical research. So this table, I think, basically sums up what we hope to do with Epigeum, in that we recognize that good research is a combination of sound scientific principles. By that I mean the effective study design, the good use of statistics, the attention to bias, the strong and defensible hypothesis. But then it also requires these very important good quality practices of data management, of research management, of record keeping, of quality assurance of the research we do. And one without the other is just not sufficient to result in high quality research and credible research. So our goal is to provide content that will help scientists do both sound science with good quality that can help them demonstrate the quality of their work.
Thank you so much, Rebecca. That was fantastic. Sarah, I am going to turn it over to you.
So Dr. Davies did a fantastic job outlining kind of the issues around reproducibility and the reproducibility crisis. But I think she made a good point, which is that we don't just want to think of it as a crisis, because that can kind of obscure some of the areas where we can really make a difference. And so I guess what my bit is with Epigeum and the program that we're proposing called RQR is, how can we address this and how can we influence behavioral change? So what we've got here is what we're calling the research workflow. And there is, as we know, plenty of variation in how this actually works in practice. But as kind of a general idea of how research is conducted, it starts with, coming up with a research topic, planning out the methodology, the protocols, working through the experimentation, iterating that as much as needed, and then assuming that you've got some results to actually communicate that. And a lot of it has to do with data. And as I'm sure Dr. Davies would agree, a lot of where we can get into trouble with reproducibility is in the data management and data analysis bit. And she made the point that really it's very often, we think, not about lack of ethics in research, but really possibly a lack of proper attention to quality assurance and attention to how every single part of this process, not just at the end, but even at the very beginning, has implications for reproducibility. So just to follow up from some of the examples that Dr. Davies already has provided, quality assurance has not always been very consistently handled in research. And that can be for a number of reasons, but science can be messy. It all looks very neat and clean when you read a paper and you read the data, and it all looks, very professional. But the way it's handled, even if it's handled in the best possible way, it's not a linear process. And so the idea of instituting a really good quality assurance practice from start to finish is surprisingly kind of a novel idea. And this is where, Dr. Davies and her Quality Central organization has really made some headway, and something that I'm sure many researchers would think should be replicated very universally. And also, it's not just that it's a nice thing to do, but it is in fact going forward a requirement that the NIH will ask researchers to address this idea of how their data will be reproducible when they apply for funding. And so this is something that needs to be thought about at the very beginning, even before the project begins. And so what we're hoping to do is provide better training to prepare researchers at different levels to think about that really critically. So here we propose at Epigeum a new program called RQR, Research Quality and Reproducibility. And as Anne-Marie introduced at the very beginning, the way that we do new programs with Epigeum is through a collaboration model. So this is the program that does not currently exist, but we are looking for collaborators, as in universities who will sign on, essentially buy into the group, and work with us to produce the best quality product that, and we rely on those collaborators, as we do with our lead advisors, including Dr. Davies and our other lead advisor, Richard Koiko, who's in New York at SUNY Medical Center, who will help us to create the best possible program that will be published. So the objectives of our QR, as you can see here, well, I think we've kind of already covered what the objectives are, but the audience, I suppose, is anyone even starting at the graduate school level. So once, anyone who is starting to do research, real research projects in biomedicine and also in the social sciences, because these are the areas that, according to the data about reproducibility and the lack thereof, are most lacking, I suppose, in replicability of data. So we are hoping to target researchers starting from the very early career level, but even more senior researchers who might need a bit of extra training as far as how they can really change their thinking, change their behavior in terms of quality assurance. And right here is a very brief summary of the topics that we plan to cover in the RQR program. And so each one of these headings, so planning your research, experimentation, and communicating, these are the main sections of the program. And each one of the bullet points is a course. And so this entire program would probably run about 15 hours total, with each course running 30 to 60 minutes. And again, this is a work in progress because we are going to be continuing to improve and enhance and iterate this program content outline as we collaborate with the universities. But here's what we're proposing as far as topics that we need to cover, and with a very important and very rigorous acknowledgement of how reproducibility and quality can be inserted and thought about at each stage of this process. And so, as I said, this program is meant for anyone who is doing research in academia or at the corporate, and so that could be a graduate student or junior faculty. We think that it could be really useful for anybody who is a really good researcher, but maybe could use a little bit of extra background as far as how to think about reproducibility. And so the benefits to the institution are, of course, that you always want to ensure that everything is ethical and compliant. There's always a risk to the institution when research is done that is not reproducible. And like I said before, this doesn't mean that there was any breach of ethics necessarily, but it's a risk to the reputation of the institution when something, for example, has to be retracted because it turns out that it's not reproducible. So the impacts are really wide-reaching, and Dr. Davies mentioned earlier the vast expenditure and wastage around research projects that cannot be reproduced. And so, that's the financial motivation, but there's, of course, a cultural motivation, which is that this is how we create a better community of scientists and just a better culture of being able to work together and ensure that what researchers are spending their time and money on is something that's going to drive things forward.
Sarah, thank you so much for that. It was really informative. We had a few questions pop up, and if anybody has additional questions, please feel free to enter them into the question section in the right-hand side of your screen. One that we received for Dr. Davies as she was speaking. You mentioned that the 2015 Nature article about the role of institutions was advocating for them to adopt good institutional practices. What type of practices were they recommending?
Thank you. Basically, the authors note in that article that universities typically have programs to address research ethics, again, the fraud, fabrication, and falsification, but they don't have a process approach to address some of the questionable research practices that commonly occur. And interestingly, there are good data in the literature, including self-reported data from scientists, that reflect that these questionable research practices really have a much greater impact on the scientific, the soundness of our science than the unethical behaviors, which of course are mercifully small, typically less than 2% of our science is known to be affected by fraud. So basically their good institutional practices that they recommend are, we need to get a handle on these questionable research practices. And they make several recommendations that I think will be well addressed or at least noted by the Epigeum course. One of them is suggesting that scientist groups of research individuals and departments have a more robust discussion of research methods in a formal way across departments, trying to get independent reviews of methods as a formative experience for scientists. They're also suggesting that we consider non-punitive reporting systems to make sure that if scientists notice things that trouble them about their data or the way the data was collected, or whether there are incidents or errors that occur, which are always going to occur in science, that there is a formative method for talking about those. And that's really interesting because in the quality assurance best practices world, that is a real typical part of looking at data around events. It's doing a robust look at errors and coming to the root cause of them so that they don't occur again. They're also very focused on training and standards. In fact, they recommend compulsory training in this area of questionable research practices associated with study design, statistical approaches, cherry picking, and just good research management. And they do focus as well on records and quality management, suggesting that basic research should learn from and adopt some of the best practices that are used in regulatory research that are associated with the management of data throughout the data life cycle, which is where I think quality assurance can come in and really help scientists demonstrate the quality of their work. And then they mention the incentive system, which is a very important feature here that is of interest to scientists and certainly contributes to some of our problems with reproducible research. So those are some of their suggestions.
Thank you so much for that, Dr. Davies. We just got one in, and I'm pretty sure this is going to be for you, Sarah. When are you expecting to start the development group?
Yes, thank you. So over the past several months, I've been working with my colleagues, including our lead advisors, to visit a number of universities, mostly around the U.S., but also in other territories. We're looking at Australia, New Zealand, the UK, for example, to join our collaboration. And we have a number of universities who have signed on, although we are negotiating their final agreements, and so so I guess ethically can't officially announce who they are until they're officially signed off. But we've got some really great collaborators signed up. So we are going to be launching this development group in July, mid-July, and we're going to plan to hold that event in Boston. And so that event that I refer to is the workshop. And so that workshop will be a 2-day event where all of our collaborators will meet and come together and really review the content outline in depth and review the content, review the learning objectives. As commissioning editor, it's also my job to work with the authors of the courses who will start drafting things in advance of that workshop meeting. And very rough drafts, because all of this is a work in progress. Everything is subject to change according to the feedback we receive at the workshop. So that will kick off in July, and we are very much in the process of signing up collaborators. We don't have any hard deadline for when we would like people to sign up, but we're hoping by late April, May, we will have a good idea of who's interested so that we can reserve their spots in the group.
Great. That actually brings me to our final slide, how to contact us. You will see that Sarah's email is there and my email is there, and the general Epigeum information email is there as well. So if you have any questions, please feel free to email us, or if you would like a free trial of any of our courses or to sign up to get more information about the development group, you can follow epigeum.com/next-steps. I want to thank Dr. Davies and Sarah Andrus for participating in this webinar and everybody for signing in. To reiterate, we are going to email out a recording of this webinar next week, and it will be available on Epigeum's YouTube page as well as all of our other webinars if you'd like to look around and see more about our courseware. So thank you, everyone, and thank you, Rebecca, and thank you, Sarah.
Thank you so much.
Thank you.
Great. Everyone have a lovely day.